wired out your kids as well.
Yeah. But like, oh, yeah, because like what you would need is you would need to have like a custom design like, of the whole like bed where there was like lights that existed inside your contours. Unless you're doing like making like mass production like a single wire, you have like a specific.
Still.
I'm pretty sure that's just like set up. Also, that's just not the scope for this project or for this school, right? Like you need whatever you can't really something that's being affected, right?
The wire just
Yeah, so what I'm describing is like there has to be some like specific setup out there where they have like little suspended posts that stick up
what you could do is you can have like 12% to half, maybe around 100.
Yeah.
So that's a halfway support.
Right, that wastes stock. You're talking about like re-indexing it when you float stock. Yeah, and that's not worth the time compared to slowing stock. I mean, especially for what we're doing.
So there were trucks now being stuck in town. But there's no gravity. That's right. There's no gravity.
Right. Yeah. If you use the wiring here from the International Space Station, you fluid part bottle, you will not have to break up this.
We ready to start? So group one, have you uploaded? Echo? The first thing I did when I turned this thing on was press the mute button. I thought. Give you guys a second to get that uploaded. When you're ready to start, just hit refresh on this screen.
All of these things is so required for us. This is the best step. But I'm just keeping on
You guys ready? We'll give it a minute. Does one of the other groups want to go first? I get no volunteers for going first, so we'll give them a minute to get here. I'm trying to put away my earbuds, and I'm going through all my pockets looking for the other one. Any help? It's like when I'm looking for my glasses and they're on my face.
Yeah.
All right, so if one of the other groups wants to go first, you can start first. Otherwise, we'll give it, 3 more minutes, and then you guys can go first as group one and pass the thing around later.
Justin have the part or did they have the part to worship?
He should have a part.
That's our back.
Yeah, you can put it in the machine shop.
Yeah. So. I'll bring it down downstairs.
I get it's hilarious. Yeah. But then it made 38. I think he landed, but I think he was maybe he had like because the guys were switched down. Yeah. We can pass it next like
Like file.
Yeah, I think it'll be fine to do the pass around later if you guys are ready to present.
Yeah, there's a photo.
He's got a shirt.
I don't know, it's okay. You already submitted this, right?
Yes, not to the presentation. So, just gonna keep what I have.
Is the other way?
I don't know.
Why don't you guys just go ahead and do the presentation, and you can do the pass around later if you need to. Just hit refresh and it should show up.
Go first.
All right. Hello, this is Group 1. We're having a general update on our EDM progress. So first, I want to address last week's question. So what is the start stop and why we need it? The start stop is a line of G code that's in M00 that just stops the machine in the middle of the operation, and you're not gonna keep going until you start manually. So what we need is because during the cut, if I cut around a profile like or in our case a hexagon or a gear outside profile, well after I finally cut through it, I'm gonna try to slip and I try to cut, but not gonna pass through because they just tip over and are caught in the hole and it will grab the wire with it. So right now, if the machine don't thrust, I'm trying to do whatever I want to do next, or just drag the piece with it, and you will have enough force to just either the wire gonna break or you're gonna drag your stock out of the fixture, and that's bad. So how to prevent the workpiece slippage? There are some ways that you can duct tape. If you can stop your operation halfway, you can duct tape your piece onto your stock, or use magnet or some feature like that. There's some image for demonstration, but for our case, it's just not worth the effort if we're just making 2 years. So we might as well just use a swap and fish out the piece when it's need to. Also, we did not break the EDM because I don't know what happened. Someone mentioned the EDM machine is not working. I have no idea what happened, but it's not our fault.
People say that all the time. It's usually people that don't know how to use it.
So we did finish 2 of our gears. So it takes total about 4 hours. You have an hour setup. Each gear take probably 15 minutes to cut, but sometimes the wire will have a problem threading itself. So that takes a while to figure it out. So gave it like 4 hours for 2 years. It's a bit slow, but that's generally how much time it takes. So in our operation, how we did it is I used a die instead of a pump for the outer gear. It does change the geometry slightly because it tries to compensate for the profile, outside profile, but in your case, it doesn't really make much difference since it's just a hand fidget tool, hand fidgeting, and kind of save a bit of operation time because it will save operation. So with a punch, you will cut profile like 90% through, then will bite out and do a cut-off operation. With a die, you just cut all the way through and bring it out how it came in.
Yeah. To add on to that a little bit, for actual operation, right? If we've cut in the profile a little bit, there should be slightly more backlash in the actual tool, right? 'Cause the gears won't mesh perfectly, but it is a fidget tool. It's going to wear in slightly, right? Because they're aluminum gears on a little toy with no load. But technically, right, we could also do it with zero backlash, but I think this could actually be like a functional benefit because it does also give a little bit more tolerance to the center to center on the bearing placements, right? Because if there's a little bit of more backlash or like opening between the two teeth, then your like alignment doesn't be perfect.
Also, we have our finished part here. I will pass it around. Also, I remember a few weeks ago, people keep asking what kind of wire the EDM used. We EDM only use brass wire and have some brass wire EDM used here. So if we don't pass it around, that's kind of it.
All right, and then finally, so the rest of our week, we've been working on like a guide for EDM. Should I pull up a Google Doc right now to go?
Go ahead. Yeah.
So big picture, there's kind of like three main sections we started with, and we were kind of still in the draft stage. A lot of it's bulleted out, but our expectation is that for actually useful, like to understand the fundamentals of how we got to where we are, but also how to actually make this exact part we have as a reference. If we end up doing that with the class the last few weeks. But so we're looking at basically explaining the basics of using Esprit, how like when we refer to things, where they are in the program, etc. For people who need a refresher from ME1800. The actual Esprit for milling out the stock that we used, if you want to do that on the CNC instead of on the manual mill, depending on your aptitude with either of those machines, whichever one is preferable. And then the more important thing probably is Esprit for wire EDM. So exactly how we produced the product we needed, how it could be applied to other similar parts. We did a discussion on stock preparations and like everything we needed to get the actual blanks that we put into the machine. And then lastly, there's a lot of those pictures that are still being formatted, but actually how to operate the machine. So in passing on the information that we've taken from Joel, procedure checklists, etc. So ideally, this could take you start to finish with a little bit of feedback in areas that could be unclear, how to actually make a part on the EDM safely, effectively, etc.
Thank you. Thanks for listening. Any questions?
Questions from the class? It can be the same question you type.
I guess I'm still slightly confused as to, so you were describing the difference between the punch versus the other word die. I guess I'm still slightly confused on why the die is easier.
No, it's not easier. Just save the operation.
Okay.
Yeah, it's the same. The machine doing the same thing, just less operation.
But the actual cutting is similar. Like for example, if you cut a part on a mill or a router or anything else where you're doing 2D like profiling, right? You have to cut differently when you do an inside contour because you want the cutting tool like set in, right? So it's the difference of the cutting radius of the tool essentially, right? Like if you flip those on a mill and you have an 1/8 inch end mill, then you're going to change your profile size by whatever that is, the radius of the tool, right? Or the diameter by the tool actually, right? Because you're going to go all the way in.
So it's which side of the line you're cutting on?
Yeah. Though on the scale of the size of the wire plus the overcut compared to the size of a significantly large or conventional cutting tool like a mill. Right.
I have a question. You said it's about 4 hours if you account for the possibility of wire breaks and things like that. How much of that time is the inside versus the outside? Is it split pretty even, or?
The inside has taken like 10 minutes because only just 6 lines.
Okay.
The outside take like around 40 minutes.
Yeah.
Okay.
Yeah.
It also accounts for like we were consulting or conferring with Joel anytime we did want to do something where we were physically interfacing with the machine to make sure we were being safe.
With more practice, it would go faster. It'd be like an hour.
Well, the actual machine time would still add up. I think it would probably be more like 2 hours.
2 hours.
Yeah, 2 and
I
a
thought
half.
you said 45 minutes. Because that's per side, per gear. Got it. How much volumetrically? How much material is wasted in your process?
I mean,
So that should be something to talk about later. You don't have to answer it now.
I mean, we know it's the hole on we draw the 4-inch hole is wasted. I mean, why they have cut out the.
I'm just thinking that the part you're clamping on for your fixturing is bigger than the part that you're overhanging to make your parts. So just something to keep in mind is that you have a lot of excess material. You could fix that with different fixturing. You could probably actually fix the dropout problem with different fixturing.
Yeah, that was something like another thing. I'm not sure what they do for like actual production parts, but I assume that if you're making a same or similar parts, you can like support it from the underside, right? If you know where you're going to cut out every time.
Yep.
Right. And then also we do have like the actual like truly wasted material right around the gears, right? Compared to like the part that we're going to cut, that you cut off. We're basically making a bunch of slightly smaller blanks every time we do this, which is not the most efficient.
Sure.
We had also talked about just flipping the 2x3-inch rectangle around after you've cut out 2 of them, because then you can get the other side. I mean, in theory, I don't know if you can clamp it down, given their holes,
But that may be some stuff to note in sort of the, I don't know, your conversational part of your little guide. Maybe have a couple paragraphs about stuff like that. I think it looks like you've got a good start to the guide. You've got a lot of pictures, so pictures are good.
Yep.
Question from money.
Anybody else? All right, group 2. So you hit the speed grader button on this. Yep. And then find group 2 on the drop down. There you go.
Right, so for the injection molding group, so for our progress update, we finished our CAM and we began preparing our stock for machining. So we changed our material from LDPE to Delrin. And this was partially due to availability, but also because it has better material qualities, like impact resistance, and also it has unlike LDPE, which kind of varies from 2 to 4% shrinkage rate. This is pretty solid 2%, so a bit easier to work with in terms of shrinkage. And something else we discovered was that SolidWorks has a mold flow simulation for injection molding, and this can really help us make sure that we achieve the desired geometry, and also can warn us if there's some defect that can occur, like any like holes or gaps in the mold. So here's our CAM setup if you want to talk about that.
So Quincy programmed all the CAM, but basically there's 3 operations. There's the face mill, which just levels it so when they're smushed together, they're nice and even. It's just all the PDF information. And then it goes to the ball end mill, but I think it should just be the end mill. But it will clear out the channels for the piece. And then, and then the end mill comes in and does the little circle where the little like plastic slug basically will be. It's where the inflow comes in and spreads out through the gates to the parts. And that's that operation. I think we should fix it so that it goes through with the end mill first, kind of like does a basic channel, and then goes through the ball mill just to put less load on the ball mill. But we can work on that over the week.
Okay, so our goals for next week are to finish machining our test mold and get our first parts. And for this, we can actually, one of the advantages of injection molding is that you can create several parts with the same mold. So we can play with different temperatures and different packing times. And we can update the mold design if necessary, if the shrinkage is too much or not enough. And we also want to start making a guide for how to use the injection molding machine and prepare the die. Any questions?
You need to change your mold geometry. No, okay, this mold geometry comes from last shrinkage, right?
Yeah, so we pretty much just expand it a little bit so that following the simulation, it'll actually give us the estimated deviation from the mold geometry. Anything else?
So you've done the simulations stuff already?
We're going to do that very soon.
Okay. So I would put that as part of the guide also. So if you're going to design the mold, use the proper tools to figure out how to make the mold. But I think you should probably have some background material on the mold design, and all the stuff that you presented should be in your guide.
Yep.
Any other questions from the class?
Do you anticipate needing to make a new mold? I imagine it's probably good for like X number of shots, right? I mean, it's such little plastic. I just don't know how.
Right. It's not going to be a lot of plastic. The mold is small.
Yeah.
It should probably be
Okay.
for a while.
Get a more definitive answer.
Yes.
I feel like this might be something you've talked about before, and I forgot. But what material are you making?
Just 6061 T6 aluminum.
Anything else? All right, then, group 3. Just the one that says Speed Raider. And then find your group. Yep. Fancy.
So we're group 3. Again, this is our presentation on the 4th axis lathe. The first part that we did, we kept working on what we said last week, was the live tooling. We didn't make that much progress on it, which we'll go over later. But again, this is the same setup. And part of the issue was, again, looking at the Fusion 360 files and figuring out how to set up the G code. So I think what we did today, kind of based on the friend's suggestion, was just watch a lot of YouTube videos and try to just gain more of a base knowledge of how the live tooling works and how to set it up. And then trying to implement that. But it wasn't as successful as we'll go over later.
So we ran into some issues with Fusion 360 this week. The first one was the first day that we went into the shop to just make new parts. And we had to change the G code that was available. I don't know where the file that we had used last week went. But somebody had a file that was an older version of that one. So it had to be re-edited to make it workable. And then yesterday so then we made a test part with that, and it didn't come out, like the geometry was not what it was supposed to. So we edited the Fusion toolpath, and then we tried to save it, and Fusion was like, actually, I want to be updated, so I will not save your file. So I believe Rodrigo said that his Fusion version was being updated either by the end of yesterday or today, so he said that we can send our thing to him, and he would be able to save the actual file.
So this is our progress report. It's not quite the same picture. You can see this is the part that we made. It has a lot better finish. I think we changed up the feed and the rotation speed, so it took a little bit longer to mill, but obviously it looks a lot nicer. However, the main issue is that like this is like not the part, if you can see. We don't really know exactly why it turned out like that. It looked a lot nicer, but then we realized that like it's just not it. And so we spent a little time trying to figure that out, and this took about like 3 hours for us, like 2 hours for us to fully set up a mill. So we figured that it was a good test to have with a nicer finish and making the part correctly. But again, the cutoff is wrong, and it's just not the part. So that was a bit confusing at the end of the billing sessions.
I'm not sure the cutoff is wrong. It's just that you're going to have a burr when you do a cutoff operation, and as the cutoff tool gets close to the center of the part, eventually the cutting force exceeds the part's ability to stay one piece, and it breaks. So you always get a little nub like that when you do a cutoff.
I mean, this one, I guess, are larger than we expected, I guess, which was kind of
Yeah, I think if you had been making a bigger part, it would have looked smaller.
true.
And the burr looks reasonable. It's just we're zoomed in on it so you see it. So do you know why you didn't get the shape you wanted?
We were kind of guessing that there was just an issue with the tool like settings when like the sizing of it.
No.
But
And if you simulated it in Fusion, it would have made the same shape.
yeah, that was kind of one of the like when we did the setup ground to see it on the lathe. It did look different, but this was kind of at the end of our
Well,
reserve
and
time.
I'm sure that it looked like this in Fusion if you simulated there too.
Looked different from the part that we intended.
Yep.
But we figured we just kind of wanted to prototype again and see if it finish.
I don't
Yep.
think it looked like this on the simulation on the machine screen.
It. I mean, it was like this big too on the simulation screen, so it was
On the
Yeah.
machine tool or on Fusion?
On the machine.
Because on either one you can zoom in.
yeah. Or on Fusion, it looked correct, but then when we put it into the machine, it was different, which is what was really confusing. Like the TA.
Then you weren't using the same tool that Fusion thought you were using.
Yeah, what we probably figured.
Because so which tool did you use to make this?
I think it was the tool 4 and tool 10.
Tool 4 is on those lathes. It's a 55-degree diamond shaped insert.
Yeah.
So it's really a triangle, but it's got two ends. That's what makes it a diamond. And if you look at that angle on the back of your part, it's 55 degrees. It is that angle because that's the angle that the tool shape is. So that tool cannot make the shape you want it to make.
Well, that part, I'm pretty sure. I don't think we have it on this slide, but with the Fusion, like it should have switched to the other one, to the 10, I think.
But maybe it did, but you already wiped out that material
Yeah.
with the other tool.
Yeah.
So, and I find it hard to believe it didn't simulate in Fusion exactly the way it cut.
No, I mean
And that tells me there was a difference in settings between what tool you told Fusion you were using and what tool you were actually using.
like another issue that we ran into is someone, I'm guessing at ME3820 had been using the lathes before and like practicing setups, so that one of the tool settings was set to like completely wrong. So we get this like X overrun or Z overrun constantly, and like having to change that. So it was kind of some mismatch between.
Yeah, I mean those are sort of the typical things that you come up with in the shop, especially with multiple users.
Yeah. So.
But yeah.
So I guess in the next upcoming week, we have a couple tasks. Definitely still learning more about Live Fusion and trying to implement that based on what we've learned literally YouTube videos, and then really refining the Fusion 360 program. We're just still having a lot of issues with it and having to get a lot of help from outside sources, which has been great, but kind of hoping that we can figure it out ourselves and maybe be able to be a bit more like independent in the lab, because we're kind of relying just on Rodrigo's help with the TA or the lab monitors. And yeah, again, the post-processing of it, which they want us to help figure out a bit, and including the live tooling. But then we're just kind of refining our lathe machining skills. Our finish was a little bit better, but still the part was wrong. So we need to figure that out. And then again, creating final part and refining our tutorial.
So the questions from last week's feedback. The prototype part took about 5 minutes to actually machine once the setup was done. We haven't tried adding the thread. We're gonna hand tap it. Diameter of the stock is 1 inch.
And then kind of figuring out how fast we want to spin this the part during the operation. It really just depends on the chuck. Like if the chuck's larger, you have to keep it lower. If it's a smaller part, or smaller chuck, you can do it larger. I think the max we found was like 4,000-ish, but it really just depends on the chuck you're using. And then whether or not kind of using Fusion, if it easily gives you G-code, assuming there's kind of no software issues or issues with that, yes, you can just save the G-code to a disk. There's actually like a floppy disk that we were using, which is kind of interesting. And then kind of what we do in the future to prevent the mistakes that happened last week, would just really just be careful and making sure that there's a lab monitor or assistant there to help us, just what we're trying to do before we even start the machine, making sure they double check everything and are there when we start it. Are there any questions?
I have a question for the rest of the class. Is there anybody in the class that's not in their group that's really good at using Fusion to make lathe code? No. Because there's certainly people at WPI that are. And so if you know people that regularly work in the lab, especially after hours, people in the rocketry club, the SAE car, the combat robotics clubs, there are several people in all those groups that are often working in the lab in the evening, and many, especially the combat robotics club, many of them use Fusion, and they do turn parts all the time. So you may be able to find somebody there that can help out. That's outside the hours that Rodrigo's available, or that one of the TAs, and most of the PLAs probably don't have a lot of Fusion experience.
I forgot. How do you do the tool of that on the live tool?
We actually should be in here.
Very carefully.
Yeah.
It's the same as setting one of the other tools.
Okay.
It's just you have to figure out where the 0 is for the center and the Z. This is actually pretty easy because the 0 for the center is always in the same place.
Thank you for your time.
El Grupo Foro. It's Spanish for Group 4, right?
I took French. I wasn't know.
So just hit your drop down. Yeah, there you go. You tap.
All right. Hi, everyone. We're team
Is
4.
this the same template that one of the other groups used?
I sure hope not.
Same slide template. Did you guys copy?
No.
We've been using this since day one.
That's actually not true. We changed.
Oh, well,
It looks very similar.
might be.
Cool. All right. So first thing that we were going to talk about today is documenting the instructions for actually setting up the 4th axis in the mill. There's very little documentation in the shop about how to do that. So the process starts by grinding down the table surface in the mill itself using WD-40 paper towels and grinding stone. It removes any like small burrs that are on the surface to make sure it is as true and level as possible. And the process is repeated until there is no visible grime left on the paper towels. All right. For the setup of the machine itself, we actually have a fixture plate that we got and we talked about in the past. We have to use the gauge here to make sure that the front face of it is in alignment, and then we have to do the same process on the fourth axis as well. And that it takes a lot of time to set up, just to say. It takes a lot of very, very delicate hammering to get it into proper position.
Yeah, so that's just, again, the beginning of our instruction booklet. Obviously, more pictures and more labels are going to be added as we progress. In terms of the production progress, so we got all of the hardware that we need to fix down the fourth axis and its plate properly to the mill. So it's all, in terms of that, it's set up and ready to go. We worked on our part design, which I think we're going to get into in a slide or two. Unfortunately, we did also realize as we were setting this up, Rodrigo pointed out that we will almost certainly need at least a couple of extended tool holders, because if you just look at how tall the fourth axis is, it's very, very difficult to get the z-axis in close enough that the tools can actually make contact with where the chuck is stored. The chuck is here, and it's about 6 inches or so above it. So it can be hard for certain tools to actually reach as far as you need them to reach in order for them to perform their operations. So I believe Rodrigo's working on getting extended tool holders so that we can actually make our part successfully.
Yeah. Cool. All right. Final design. So we added some new text, and we also changed the fillet to a chamfer, which actually didn't reduce the price very much. It only reduced it by about $10. So we thought we'd experiment with that to see if it would change it drastically. It didn't, which was a bit surprising to us. But yeah, I think that's pretty much it for the final design.
Yeah, so this is our updated plan in terms of step-by-step how we're going to make the actual part updated based on the discussion we had a couple of weeks ago. So as before, we're going to start with our chuck, which I believe in this model, it's 2-inch diameter, milled down at the end to be 1 inch so it can fit in the thing. So start with facing down the two flat faces, and you can see sort of where the part is going to come out just as an outline. And then continue facing it down, get the holes through, and then sort of start the outline. We have to figure out exactly how much of the outline we can actually do safely without risking breaking the part. But get some amount of the outline outlined, and then take this back to the lathe, cut it off, and then we still have to figure out exactly how we will get the rest of the outline out. I believe our current plan is make use of the fact that we now have nice flat sides and just vise it in or something along those lines, and then just mill down the final section of the part, and then it should be finished.
Cool. All right, that's all we got. Any questions?
So what's your timeline on making the part? I do have the timeline here.
Yeah, so we're working on the cam. We were going to work on it yesterday, but we were running into sort of similar Fusion 360 issues as Group 3 was running into. So we still have to work on that. So that'll probably be done over the weekend into Monday type beat.
Yeah.
And then at that point, we're essentially just waiting on those on that final piece of hardware, the extended tool holders.
We're also waiting on some low-profile screws to mount the.
We actually got.
Oh, okay, cool.
Yeah. So.
The issues we were running into yesterday, we were opening on Fusion, but he had an older version, so he couldn't really open our parts. We wouldn't be able to show us how to do it, so we ended up not working on it yesterday. We're going to work on it tomorrow, and most likely we'll have a part tomorrow, something machined if it's not completely done.
Yeah, we'll get back to you shortly with that.
The Fusion issues that people were having, is that on your personal computer or on the lab computers?
Personal computers.
Oof, yeah, I've had problems too.
His laptop, he was able to open the part and download it. On mine, I wasn't able to do that. And what they do is just had like an older version of Fusion in 2020.
The model
Instead of 2023, whatever this one is. So he needs to get that one updated and say with IT services for that.
Has anyone tried to use it on one of the lab computers?
No, that's probably a good idea.
So your problem was with the lab computer then? So I need to get IT to update all of those stuff.
Oh boy.
Cool. Well, any other questions?
Yeah, any other questions? I think that's all we got then. Thank you.
So that was everybody, right?
Yeah.
Okay. So my goal at the very beginning, and granted this was before we had decided what the project was, as we were formulating it, my sort of stretch goal, my ideal outcome would be that we'd finish making the instructions in the first 2-3 weeks, and then that all the other groups would use your group's instructions in like the following 2 weeks, and then give you feedback, and then you can refine your instructions to make them better for the end. So I don't think that's going to happen. Anybody think they can push hard and make it happen? Right. So I think based on and again, you know, we've never done this assignment before. So when we assigned it, when we started it, I didn't know it was going to happen. And so part of it was to find out, how does an assignment like this work, and what are the correct expectations? And I think the correct expectations would be to have that completed tutorial done by the end, and to have collectively made one finished part. Right? We could have more pieces, right? We could have more than one finished part, but I think a reasonable expectation, because what we got, 2 weeks left, and one of them has 2 days off.
Yeah.
I mean, the 2 days off. One of those days is what, advising day,
Yeah.
and then the other day is what?
Well, let's say so.
I just said Mother's Day. I was like, I'm pretty sure it's not Mother's Day. And maybe we should have Mother's Day off, but we do because it happens in the summer. Excuse me. So the lab will be open on Thursday, Friday next week. So if people want to come in and continue working on stuff, we'll be there to help you. If it would help you feel more well to make more progress on your project, for example, there's certainly be people there to help you with that. And I think that's really the intent of the wellness day, is to let people do the thing they want to do that day. And if the thing you want to do is work, then you should work. And if the thing you want to do is, I don't know, go to the beach, drink tequila, you should probably do that. But you should probably find a beach that's warmer than the ones around here. Anyway, so does that sound like a reasonable conclusion? Is that if everybody's got an instruction set, I don't think we'll have the requirement of having had another group use your instruction set to make a part, but it certainly would be a bonus, right? So if you finish your instruction set, because I think yours will be done. Yours will probably be done next week, or at least a draft of it that somebody can step through. So if you can do that, that's perfect. But I think minimum requirement is complete an instruction set to make your part. Does that make sense? And hopefully we'll have at least one good part. And once we have that set of instruction sets, other people could come in and actually go through those steps, make that part as sort of a training thing. If somebody's, I want to learn how to use all the different kinds of machines here at WPI or something, we could then use that as sort of a training for when people come in. So I think it's tremendous value. I think we're learning a lot. I think we're all learning a lot of lessons, both about how to do the steps we're trying to do, and also about how to interact with each other and how to figure out the process of making this part with 4 different groups. Glad we didn't go with 5 groups. 5 groups would have added one more level of complexity, huh? So I'm actually really pleased with how it's been going. Hope everybody else is learning something and it's working out. Anything else for me?
This is a silly thing, but there's not a self-assessment assigned this week. Is it okay if we don't do that? There's less quizzes this week.
Huh. Well, that's my bad, but yeah, free pass. Wellness day. We'll have 2 tomorrow. We'll do 2 next week.
Awesome.
Oh, we don't have class next week on Thursday, right?
That's correct. No, there's not.
Yep. No update. So yeah, if you need me or need feedback, just reach out, make an appointment, or stand in front of my door until I bump into you. That method works too. It just takes longer. All right. Perfect.
So just